Hi, welcome back. So I'm going to walk through another presentation from Intel, and it's relative to data collection and the enhancement of data. So when it comes to data, man, there's so much data out there, and we've gone through this aspect of it, but like I said, up front, the data is so important. And where's the data coming from? What type of data is there? How much data and what attributes do I actually need? Is it going to be reliable? There's so many things that come into play. And there are so many different data sources available to us today. It could be data that was generated by people. That may not be very reliable. It could be data that's generated by the Internet of Things or generated by a machine. Now, the Internet of Things is a network of sensors, could be cameras. They are networked devices with IP addresses. We've got public websites. You could get data from a public website, access it directly through an API, or you could do web scraping. It could be legacy documents that you're using as a data source. It could be some multimedia, variety of different media. Okay. Now, human-generated data, or social media, has grown so much, and one of the things that we're realizing now is how unreliable the data may be because the intent behind the individual that's created it, the data that's been made available, is there to mislead, if you will. There's a lot of data. Within the last 2 years, 90% of the data has been created. Now, this is related to the fact that the capacity of computing is doubling, and it's even beyond doubling now. With a video that I'll have linked into the course later on from 60 Minutes, where they talk about quantum computing and how close that is to being a functioning, reliable reality. That's so different than what we use today, the types of conventional computers we use today. Okay. So the data that we have being accumulated and acquired as the capacity of computing grows, our ability to capture and collect and archive data grows as well. So we've got different types of APIs that we have to allow us to link to the different social media sources to capture data from them. I could go access books. There's websites that allow us to access all that stuff. We've got the Internet of Things, like I mentioned. Sensors on cars, sensors on the roads. I know that in the city just north of me, Jupiter, Florida, they use cameras to track vehicles as they move around. And those cameras, when there's a crime, they can go back and look through those cameras to see where did cars move, do license plate readers based on the imaging, and find out whose car it is. So much that they're able to do, and that is an IoT device. That camera has an IP address, so they're IoT devices. We've got IoT devices used in the medical field, in law enforcement, in industry. There's so much that's going on, whether it's a sensor or a camera. It doesn't require a human for interaction or application of what it's doing. So once we've deployed it, it can be strictly autonomous. So how do you access the data? Sometimes it can be awkward, expensive, or however, but there's a couple of examples. I have an app on my phone. I can control the thermostat in my house from an application. That thermostat is an IoT device. I access that device over the network using its IP address. The application is interacting with it. It collects data over time based on certain metrics. I can have it turn off at a certain time, change the settings, the temperature that I want. Whatever I want to do, that is an IoT device that I can control remotely. I can capture data over time, see how long does it run, whatever it may be. I've got an IoT device on one of my saltwater aquariums that keeps track of all the chemical analysis, the pH, the temperature, the salinity, all those things. Each one of those is a different sensor capturing data. Based on that data, the system then reacts and may dose it with a chemical, run something through a chiller, turn a heater on, whatever it may be. Okay. We've got public websites that we can access. You may have read an article or heard about web scraping, and that web scraping is a problem. Now, web scraping is where we can use a computer program. Let's say I wrote a program in Python to perform web scraping. And essentially what it's going to do is connect to a website and go through and capture all the data that it can from that website. It may capture data that's available at a specific point in time. It's whatever I want it to do, but it's all done programmatically. Now, some individuals access that data inappropriately or without the correct authorizations. That becomes an issue. You may have read an article about ChatGPT and the issue that data that is being utilized in ChatGPT was acquired inappropriately. So the owner of the data, the source of the data, has disputed the fact that ChatGPT is utilizing data they were not authorized to access. So we've got so much data out there, but what data you can access, how you access it, who accesses it, these things are all controlled, and there's legalities that we need to deal with. If we're talking about medical, it could be HIPAA. Okay. So web scraping, programmatically access the web page. APIs are our interface to the website itself to get directly into the website and the data. We've got legacy documents, and you think about that as like legal records or medical records that have been around for a while, and they may not be in digital format. They were pen and paper, pencil, whatever it may be. And that's something that over time they're being scanned. But when we go to scan those in, AI is what scans them in and captures the data, and that becomes problematic depending on how it was written and being able to, we'll talk about another module, I think that's module 9, where we deal with NLP, natural language processing. We have AI has the ability to recognize characters in the English language as well as other languages and identify words, sentence structure. It can look for specific things And then from there, we can take a handwritten document and get inferences from it to be able to identify data in that document. We'll talk more about that in Module 9. We've got multimedia. In the latest iteration of ChatGPT, there's now video and images that are being used by that application. So the amount of data has grown, not from just text that we had before, but now we've got images, audio, and video in here. What we're working with, the data we're working with, has become so immense, and it's growing every year exponentially. So at this point, we should be familiar with different types of data, whether it's an image, text. As we deal with programming languages in other courses, the type of data becomes important. Now, the word data type, or the words data type, or the label of data type, in programming specifically means the rules that apply to how I'm storing some data. So when we say the type of data, I'm storing data. Well, what type of data is it? Is it a word or a number? Well, does it matter? Yeah, it matters. If it's a word, we need more room, and there's different rules that apply to storing words. We're not storing numbers, we're storing characters or letters. If I'm storing numerical data, there's different types of numerical data. Are you talking about an integer? Maybe a floating decimal point or a decimal? So the rules, how much space it takes, and the rules associated with storing the data, keeping the data, and accessing the data, what you can do with the data, that defines it as a type of data or a data type. So I need to know what the data type is on how to store it, how to access it, what I can and cannot do with it. That's a big deal. How much data is there? All right. In different languages, we refer to an integer as an int. We've got an integer is a whole number, floating point, a float. It could be a decimal in certain languages, programming languages. Categorical. So categorical, we can say, let's say, we talked about the iris data set. We've got 3 classes of flowers. If I look at it as 3 different categories or classes, I don't want them as words. I want them as enumerated data. So I want it as class 1, 2, or 3, or 0, 1, 2, and not a word, because the amount of space associated with a word, it's the rules. Remember I said the rules associated with the data types. So enumerated data, it's better when we're doing what we're doing in machine learning and data science. We've got ordinal, which means that it's in some kind of order, low to high, bad to good, whatever it may be. Binary is just a Boolean. It's one or the other, on or off. This is the difference between the common computing today and quantum computing. We look at it today as the coin is either heads or tails. In quantum computing, there's so much more than just heads or tails. Diagonal, vertical, different degrees, directionality. There's so much more data associated with that same thing, but now it's not just one or the other. Well, that'll come up in that video that I've talked about. We've got time or date time data. It's associated with how you format it. What are the rules associated with time? Is it date, month, year, time? Or is it month, date, year, time? Matters. Is it just year? What is it? The date time is the data type, and within it are different formats. We've got text, which we traditionally would call a string of characters. We've got images. We're talking about JPEG, PNG, bitmap. What is it that we're talking about? Each one has its advantages, disadvantages. Audio. Now, the shape of the data itself is when we talk about the features. We want to identify the number of samples and the features that we need to solve the problem. How much data is enough? How much data is not enough? Do I have enough features to actually classify things? If I only have one feature or two features, man, may not be the features I need. Are there other features available to me? Okay. How many samples do I have? Mentioned this before. Overfitting, underfitting, we'd mentioned before as well. Okay. And how can I increase the number of features? I can only do so much. Well, I can change things. I may want to reduce the number of features so that I don't make the system work harder than it needs to. Okay. So the data sets themselves, where they come from, how big they are, there's data available to us in so many different places. I use Kaggle a lot in a variety of different courses. And they've got competitions where it's data science. They're doing data analytics and machine learning and deep learning, and they apply it to standard data sets. Everybody uses the same data set, and they apply different models to try and come up with the best result. ImageNet, huge database of images. Now, databases of images, given this is my area of research, this is a big deal. These databases are growing so fast, but not all images are created equal. Some images are great, some images are horrible. The resolution's bad. The pixelation on it, how detailed is the image? Is it grayscale? What is it? We've got a variety of different image sets there. We've got natural language data sets available to us. As I said, we'll talk about NLP in Module 9. That's Chapter 6 in the text. Okay. So when it comes to the data, we've got to prep the data. We've got to go through and make sure that the data is what it's supposed to be. If there's something missing, do we get rid of that whole record? Or do we say, all right, based on all the others, I can predict what that would have been? Really? You can predict it? Some folks think they can, and they just insert a number in there based on statistical values. Here's what would likely be there. I prefer to just delete it. If I don't know what it is, I'm not going to say I do. I'm not going to assume. Go with what I know. We may not have enough data to do that. We may have to use some predictive, or sometimes If I don't have a whole lot of data available, let's say images, I don't have a ton of images available to me. I can take the images that I have and duplicate them by rotating the image. So I've got the standard image, which is a vertical image. I take the same image, I rotate it 45 degrees and make a copy. Another 45 degrees, make a copy. Another 45 degrees, make a copy. It's still the same image, but it's just being rotated. It's still the same classification. It's helping the model learn with different perspectives. I want to impute missing values. This, as I said, can be dangerous. Image analysis, or in using images, we call it in-painting. We use averages and then go from there. So we want to go through and do a lot of pre-processing. I want to make sure that, am I dealing with something that's ordinal? Am I dealing with words or numbers? Male or female, 0 or 1. Red, blue, green, 0, 1, 2. These things matter. All right. So how I go about it makes a big difference. How the data is labeled, the data label identifies it as the feature that it is going to be. Okay. We talked a little bit about semi-supervised. So we've got challenges, and the challenges are, most of the time, we didn't come up with the data. We can only go with what we've got. And we need to go through and find out what issues exist in that data. Spend a lot of time figuring out how bad is this data. Don't assume it's great. Dig through. Look at the statistics on the data. In future classes, you'll be able to take that data set, bring it into a Python data frame, perform statistical analysis on each row, record, feature, everything, and get an understanding of what it is you're working with. What's missing? What do I need to do to clean up the data, to wrangle the data? Okay. The data may have biases in it, and you may have heard at some point where people had used AI to show me a picture of a programmer, and the programmer was, or the image that was presented was of some specific individual based on biases in the data. It's something that wasn't caught for quite some time, and then when it was, oh, how are we going to deal with this? So the images were predominantly men, not women. Does that mean that women can't be programmers? Absolutely not. But there was a inferred bias in the data. The bias existed, but it was a result of the data that was being used. We've got to go through and fix it. We've got data leakage can be an issue. We've got outliers I mentioned in the past. Big issue. Imbalanced data sets. Wow. We're trying to classify this, but the data set that I'm using only has 2 members of one class, and all the rest of the records are another class. Not quite a good data set. Okay? So with that said, I'll see you in another video, another module.